Hello everyone. Today let's solve two-sum problem on LeetCode. This is very common and easy problem. However, you will learn a lot from it. In this video, we will simplify problem solving, coding, and capture all the nuances that you need to be careful. To also check out mock interview experience, also check out the link in my video description. Let's get started. For two-sum problem, you will get one array of integer and one number of target sum. And your task is to find the indices of two numbers that add up to the target. For example, if the target equal to 9, you may see that, hey, number 2 and number 7 here produce the target sum. And we will output the 0 and 1, which is the position of these two numbers. And similarly, if the target is number 6 in the second example, we will see that, hey, the number 2 and number 4 here give us the target sum that we want. And this is in this number 0, number 1, number 2, yeah, because the position number 1 and number 2 give you the target sum. That's why it output 2 and 1 here. Okay. This problem, if you think about it, you could solve in the most straightforward way. So let me give one example. You may solve this simple method. Two layers of for loop. The first for loop, you will scan the left position, and then the right for loop. The second for loop, you will start with the next position here. And then in each for loop, you will keep iterating all possible combination. For example, like when the second for loop, it will go through each of these items. Yeah, in this approach, it will be complexity n square. The code is really simple. Actually, it will look like this. Let me just show you how it looks like. Although this is not exactly optimal solution, yeah, it works like this. Notice that on the second cursor, we want to make sure it's not duplicate, right? Because that's what our task is request us to do. Avoid duplication, so we start the second pointer always a position next to it. In this way, there's no duplicate between left and right pointer. So nums.length rg, and then if the value, just keep in mind that we will get it from your number list plus nums rg equal to your target sum, which is target. Then you will find the output here. Yeah, then we find the output. I won't complete all the coding yet, just to show you the basic concept. Output position at LF and RG. Yeah, however, this is the n square complexity. The upside for this approach is you don't need to define any new memory at all. Yeah, you can just process everything directly from your input list. And then you do the computation. Yeah. However, you can notice that the input constraint of this problem, basically this is your n, right? N, which is the size. Yeah, this is your n here. You can see that it's about 10k. Sorry, it's actually 10k. 10k. Let me write. Oops. Okay. So if you do n square, it will become quite really large number, which takes like quite long time to process. Now let's try to come up with a way that faster than n square. Yeah, this approach is n square. So let's try differently. Let's try something that more creative. You can try to come up with more creative approach. For example, when you get the first index here as a left, For the case where your input array already sort from smallest to largest, you actually don't need to go through the RG pointer in every location, right? Mainly because if you know that your first number is number 2, and in order to find the target sum equal to 9, you need number 7. Mainly because 9 minus 2 equal to 7, so that's what you try to search for, right? Instead of go to all the candidate here, you can do binary search in this range instead. So this means that you can do binary search. So in this case, binary search complexity is big O log n, right? And then for the first pointer, you try all the number. So this will become n multiply O log n, also known as n log n, which is much faster than n square, mainly because if your n is equal to 10k, your log n of 10 is pretty small. Let me try to do the math here. Sorry that my brain is not the calculator, but I think it's about 2 power, is it 2 power 10 equal to 1024. It's about like 12 to 14, around that. Yeah, but anyway, you can see that the total combination is much smaller. And the tricky thing is, in this problem set, the input might not sort for you. So before you do this approach, you may need to sort the input array first. Now to recap, you have you have two approach. Now the first approach is to do brute force or combination. Second approach is try first number in all position, but the second number you do binary search. However, that's still like not as simple enough. Yeah, let's come up with the third approach. You can see that the tricky thing about this problem is that you have a lot of back and forth between these two cursors, right? Are there ways a do with one iteration and done? There is actually a way to do. So let me try to start the new the new approach here. The other approach is we will do one round. Basically, we will scan from left to right like this. And in every position, for example, when we reach number 7 here, if we have a way to remember what are the number that happened before me, yeah, basically like let's say if your number is 7, then you hope to see number 2 before you, right? If number 2 exists, then we will get our target sum. You can use the hash map to solve this memorization problem. Yeah, basically this is your input array, and then you will create another hash. Let's say that let's define it as previous. Yeah, this one basically you will create the storage, and whatever number that you have been scanned to, you will mark it as a key. Say that, hey, number 2, you have found it at position 0. And if you keep scanning, let's say you reach number 11, by that time we already scanned number 7, right? So your hash map will also remember the number value 7, and then you say that, hey, we found it at position equal to 1. The reason why we store the position in the hash map is because we will need this position ID to produce our final output. Yeah, so that's a rationale why like you would store the position index as a value here. If the problem doesn't require you to output position, you can just simply mark as true or false, something like that, to remember that yes, you have found this number. And the code will look like this. Let me show you. Okay. So we will scan the pointer from left to right, so that would be nums.length, and then we will create additional hash. Yeah, that's actually the one constraint of this approach. Basically, you need to create a memory to remember. So you will lose some memory with the largest size equal to n, which is your input size. But the benefit is you do only one round and you get the big O(n) complexity. It will work like this. For example, first let's make sure we handle edge cases. If num.length less than 2, so in this way it means that our input array has only one size, and then in this case we would not be able to find any output, right? So we just return, let's say in this case we return empty list. In the real interview, just check with interviewer how they want you to handle this kind of case. But this one basically like input is too small to find any pair. And since we already covered these edge cases, what you can do here is you can mark your first number, right? This is the value that you have visit, and you know that this is the first position. And when you do that, it means that to find the eligible output, you would start from the next number, which is equal to 1, and we do one round here. So what we will do here is, if previous, actually we want to find basically what we need is we need target minus nums I, right? Because we already got the one number, so we want to look for the other one. So we will look up from our hash here. Yeah, if someone defined it before, then it means we found our solution. So in this case, I think we will do basically because our hash remember all the previous position that contain this number. So we will return this with our current number. Yeah, so basically this is we found solution. But if it doesn't match, then we keep scanning. So yeah, that would be our approach. Yeah, for the case where it's not, then we will need to mark the current number, right? Current number is num I. Then we have to mark that we found it at I position so that we can use it later. And if we reach the end of the for loop without hitting any solution pair, then we would know that this is no solution found. Yeah, let me double check if I missed anything. Yeah, so yeah, we can actually try with different input. For example, 3, 2, 4, and target 6. Right? Let's try 3, 2, 4, and target 6. Yeah, in the real interview, you also need to show how you proof check your code as well. Yeah, and we can try with just some like quick example here. So in this case, we have the array size equal to 3. So we probably like continue to the next line, and then we have the previous hash here. We first make sure that we remember the first number, which is number 3, at the position equal to 0, and then this will be our hash. When we get to this stage, then we scan from I equal to 1, and then we keep scanning, and target is 6. So this line, it means that in order to get to 6, we need 6 minus 2, we need number 4. But since we scan from left to right, the number 4 here doesn't exist. Yeah, because we have only number 3 previously, right? So in this case, it won't pass this if condition. And yeah, maybe when I type I miss some number. This should be equal to I. Yep. Then for that case, we remember number 2 is at position 1. And then we iterate to the next element inside the for loop. In this case, our need num will become number 2 now, because num I equal to 4, and then target equal to 6, right? So need num equal to number 2. And in this case, our previous hash like this, have number 2 defined now because it's previously found number. Then it means that we found solution. Yeah, so we will return preview need num, which is this number, number 1, and then the current index, which is number 2. So we will return 1 to here, which should match with our example output. And that's it. Yeah, there might be like some caveat here. Keep in mind that in the real interview process, it is pretty interactive. So the task that you receive may be different from this. Just make sure you clarify the problem statement with the interviewer. Be yourself, understand your code. And if there are hints or if there are something where you miss, just show that you be able to understand, be on the same page with the interviewer, and be able to catch the problem and test your code by yourself. And that's it. Again, if you're interested to check out what the mock interview experience look like, we build AI for you to try out so that you can rehearse the interview at home. Check out the link in our YouTube video description. Thanks a lot.